Hi, everybody. Welcome to today's live lesson. I am super excited to kind of dive into some of your questions that I know you desperately want answered during this exam time. And so, just while I let everyone join the live and people get notifications so that they can join this live with us, I'm just going to cover all of the things that I want to do in this lesson so that you know what we're going to cover. And I'm going to do kind of a different kind of live lesson where I'm actually going to focus a little bit more on improving your exam answering skills and kind of touching on some points that I've even noticed in my own matrics and how they've answered their questions this exam season so far. And maybe you can work on these before you get around to your own exams. So without further ado, what are we covering today? We are going to be looking at some homeostasis information, more about how to structure your answers and less about the actual homeostatic explanations for like carbon dioxide and glucose. We're going to not focus our attention on that too much. I'm going to just give you some top tips on how to get full marks every time when you do those questions. And then we're going to do a little bit of endocrine. I'm going to specifically focus on a gland that many matrics always overlook, which is the thyroid gland. And I just want to run through it. I'm also going to be referencing a cheat sheet page out of my study guide when we do the endocrine system. So if you love the page and you love the note, then get your hands on the cheat sheet. If you are, of course, a member of my YouTube membership, which is not the same as being a subscriber. But if you are a member of the Rescue Me membership, then you get free access to my study guide. So I don't know why you guys are not using it, because it's literally filled with how to get full marks. And then once we've done the endocrine and the thyroid, we're going to move on to genetics. I'm going to decide how I'm going to package that for you. It might be a little bit of a mixture between just covering genetics, the three main kinds of dominance, explaining them very quickly again, a quick, easy kind of cheating way to remember everything. And then from there, we are then going to cover the application on a question. Okay. Lovely, 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 lovely stuff. So if you have any questions, by the way, please put them in the chat alongside. I can see the chat as we go through the lesson, and I'm going to go a little bit slower today because it's only a members live. So sometimes you need more time to write your question out to me. So please do. And without further ado, I'm going to swap my screen over. So don't worry if I disappear for a second. I'm just going to swap my screen over onto my whiteboard. Okay, so this specific focus is about acing these exams, and not just these exams. Everything I want to tell you now, please also use it for your final exams as well. Okie dokie. Right. So what I want to do is I'm going to zoom out, and it's an infinite whiteboard. So if you see any little pictures and stuff like that, we're going to get to it soon. I want to bring your attention to and focus quite intensely on homeostasis. And the reason why I am bringing homeostasis up is because I feel like grade 12s don't spend as much time studying homeostasis as they should, and you probably never get full marks. And often homeostasis has like 6 to 8 mark questions, right? Which is a lot of marks. And often you seem to probably be getting like 4 out of 8 or 2 out of 6, and you feel frustrated because you're not getting full marks. So what I think is very important to understand about homeostasis is that homeostasis is linked to negative feedback. So I always explain negative feedback, and I'm sure your teacher does the same, as kind of like a seesaw with a balancing beam over the top. And basically, your body wants to stay level in the middle, right? The thing is that levelness is almost never reached, or it's never perfect. And so often what happens is one side of the seesaw goes up and the other side of the seesaw goes down. And that's normal. So you would end up with something like that, right? And so essentially, you have something that is at a high point and something that is on a low point. Now, what could that something be? Well, remember, homeostasis can be linked to hormones and is linked to hormones going up and down. And those hormones affect substances in your body like sugar, carbon dioxide. What's another one that we do? ADH. Oh, so actually, I'm going to take that back. It's not ADH. I would say that that's water. We regulate water, we regulate salts or ions. And so homeostasis is about keeping these substances level. So if this was the sugar seesaw, for example, right now we have a really high level of sugar, right? It's too high. We need to bring it back down again. And this is the problem. Many of us are not writing our answers properly. So, this is what I want you to write down, or I want you to kind of make a note of if you have paper with you. And keep this with your notes when you study homeostasis again, or if you still have it coming up, if you haven't written paper one yet. But a lot of us don't realize that we are always doing some of these functions. For example, and I want to use this one specifically, when you do homeostasis for temperature, right? So you want to regulate your temperature. And remember, we want to keep our temperature somewhere in the middle here of like 37 degrees, right? It can go up or it can go down, and we want to keep it nice and balanced, right? I want you to know that when you regulate your temperature, you are always sweating. Now, I know that that sounds like it's not possible, but just stay with me here. You are always sweating. You are just sweating more or less, but you are always sweating. Just like you are always regulating your sugar, you're just making more insulin or less insulin, more glucagon or less glucagon. Likewise, with your carbon dioxide level, you are always regulating it. You're always breathing a little more air in or a little more faster out. You're either raising your heart rate or you're lowering it, but it's always going, right? Like your heart is always beating. I think that's a nice example. Your heart is always beating, right? It just beats faster or it beats slower. And the problem with matrics is that they are not using the words more or less in their answers. So let me give you an example. If you were going to explain vasodilation, which remember is when we are in a hot environment. If you think of it like this, when you are explaining vasodilation and it's a hot day, you need to use the word more every single time you talk about a change. So you cannot just say you will sweat. No, there will be more sweat. Can you say there will be blood sent to the surface of the skin? No, more blood sent to surface of skin. Can you say, and the sweat evaporates? No, more sweat evaporates. So, do you see what I'm getting at here? If you don't, and I'm just going to move this over a little bit so my picture is not covering it. If you don't use the word more every single time, then you're not going to get the mark. And trust me, maybe your teachers now are not telling you this, but I'm telling you, as someone who marks final matric papers and we go and we sit and we do moderation and we do memo discussions together and we learn how we're going to mark your papers, if you don't write more sweat, more blood, more sweat evaporates, you will not get the marks and you'll be so confused. And you'll be like, but I studied and I know I gave the right answer. So why didn't I get better marks? I think I'm going to go send my paper for a remark. Well, this is the reason why you're not going to get more marks, because you didn't use the word more or of course. If this was the opposite, so let's just move this out the way, and I'm not going to write the whole thing out because you'll get the idea. If you had vasoconstriction, right, then that's on a cold day, then you would have less sweat, right? And then less blood is sent to the surface and less sweat evaporates. Do you get the idea? So please make sure that you are always using the words more or less when you are writing out your homeostasis question your answer in full. So please, please, please focus on that. Another top tip that many of you may have seen in my study guide, in the cheat sheet, which of course is available to everyone, but for members, you can get a free copy of it if you are a YouTube member. In the cheat sheet, there is a template answer that you should use to structure your answer in the exam. And again, grade 12s, I'm trying to make your life easy. That's the point of the cheat sheet, to make your life super easy so you study less, so that you can spend more time on other subjects. You don't have to spend like days on life sciences because there's so much to remember. And I think that's always everyone's biggest issue, is like they have to remember so much. If you use this template, you can use it for homeostasis, endocrine, and the nervous system, because they all follow the same idea. And this is it. When you structure your answer around homeostasis, you always begin with a stimulus. So state the stimulus in your answer. If it was in the nervous system, the stimulus might be light. If it's a hormone or a substance, maybe the stimulus is sugar. Like if it was for your glucose and, your insulin. Whatever the stimulus is, state it in your answer. Say it. Say the stimulus. Now, with a stimulus, someone must feel the stimulus, right? Someone must experience the stimulus. And so when you are experiencing the stimulus, you are going to need, I'm going to change that back to black. You are going to need a receptor. Now, don't just say receptor. Tell me what the receptor is. And so there are many different receptors, aren't there? There's the receptors in your ears. Maybe it's the cristae. Maybe it's the photoreceptors in your eye. Maybe it's the chemoreceptors. Sorry, writing that really slowly. So you've got to mention the receptor. You've got to be specific. Go say what kind of receptor it is. Right. Now, the stimulus sends a message to the receptor. The receptor receives this information and it's going to send it on to what we call the control center. Now, there are different kinds of control centers, as we already see. I'm going to move this up. The control center could be a brain, part of the brain. It could be something like the pancreas, right? It could be so many different things. But the one key thing here is there's always a control center. Now, the control center, as the name suggests, is going to control and filter in the information, and it's going to create a corrective measure, which essentially, everybody, a corrective measure is a decision that you're going to fix something. You're going to change something. Remember, our seesaw is not balanced. We want to change it. So the corrective measure could be secrete more whatever, sweat, secrete more insulin, okay? Or reabsorb more water, reabsorb more salt. That can be the corrective measure, okay? So secrete more, and I'll put here reabsorb. Let's say reabsorb less. Let's change it up, make it different, okay? That's the corrective measure. That's the instruction. Now, somebody has to carry out the instruction, don't they? And so the corrective measure is sent to an effector. Now, there are again many, many different effectors, but the main two effectors that you should always know, the two categories, are some kind of muscle or some kind of gland. So that's where it comes into, well, you secrete more insulin, you secrete more angiotensin. And let's hope that everyone knows what angiotensin is, because now saying it out loud, I feel like a lot of people don't study salt enough, and that's what angiotensin's for. Okay, right. Then the effector, okay, has to do something. And so they are going to return to the norm. And what the norm is, everybody, is normal. It just means go back to normal. And so whatever that is creates a result. So if, for example, and I'm going to write it down here, let's say the result was less urine or more sweating. I'm just giving different examples here. That's the result. Now, you'll see I didn't write anything down below return to the norm, because that's just like a standalone statement. You can say like the sugar returns to normal, the muscles correct the posture and return to normal. The result is all about what happens at the very end. Do you make less urine because you absorbed more water? Do you sweat more because you vasodilated? And so this is your template answer that I think every single matric in the country should be using. It is foolproof. You cannot get less than full marks if you use this template and you use it correctly, meaning you substitute in the gland or the stimulus or the whatever it is correctly. And most importantly, if you use this template, make sure they are asking for the whole homeostatic function, the whole loop. And they are not just asking, for example, and I've seen this, they're not just asking for this end part here. I'm just going to take my highlighter, this end bit here. Oh, actually, let's take a different color. This end bit here. Sometimes they ask for just this bit on the end. They don't want to know the stimulus. And how do you tell the difference, ma'am? Because now you're telling me something else. How do I tell the difference? Well, they won't ask for the whole. They won't say something like, describe the negative feedback or describe the homeostatic control of glucose. That would be the whole loop. If they want just that end bit, they would say, describe the role insulin has in maintaining glucose. You could say all of this stuff at the beginning here, but it's not going to get you any marks. Okay, what is going to get you marks in that example is if you just go straight to, well, let me tell you the role. The role is, because we've already jumped ahead, we've already gone past the control center. The role is we're going to absorb more sugar, and that's going to store it in the muscles and the liver of the body, and we're going to return to normal. Therefore, there will be less sugar in the bloodstream. Do you see how you can like make the answer shorter? Now, I'm going to take a little quick break and just have a look at everyone's questions before I move on. Thank you, everybody, for the lovely messages about doing well in your exam. Gio, I have a question. In what two other processes is the chorionic villi involved in? What two other processes? Well, the chorionic villi are there for the formation of the placenta, the chorion, And I'm going to guess probably they linked it to the blood vessels that grow in the umbilical cord. It's quite an unusual question if they asked you that, because it's quite a detailed question. It requires you to know a lot about what the chorionic villi are. But I would say those three things. So like the formation of the placenta, the formation of the chorion itself, and then the fact that the chorionic villi become the umbilical cords, artery and vein. Can I go through a practice question using this template? That's actually such a good suggestion. I'm going to actually, you have to be patient with me because I have to scroll through all my saved questions here alongside. You can't see that now, but I'm just going to scroll through here quickly. If you have any more questions, please just let me know in the chat while I look for a homeostatic question. Let's see, is this one worth our time? No, I don't want to use this one. Oh, and by the way, another homeostasis section or even endocrine section that people don't study enough or realize it falls under this section is also the menstrual cycle actually is technically also an endocrine gland, and therefore they could ask this question on it. Let's see. I'm sure I have one here. Let me just see. Let me see. Do I have a homeostasis question saved somewhere that we could use this? Let's see. Let me see. What's this one? Oh, I mean, you could also use it for the reflex arc, but I don't want to use that one because that's very obvious. That's the main one that I actually am looking at right now, that I don't want to do that because everybody knows how to do the reflex arc. I'm assuming everybody here knows how to do the reflex arc. Actually can't find one now. I'd have to look really long and I don't want to waste anybody's time. But what I will say though, who actually asked that question? Let's see. Zeba. If you actually go, Zeba, if you go into my exam question playlist where I actually walk through everyone's questions, you will actually see that there will be homeostasis ones. And I will use this template in those to practice them. So if you have a look in that playlist, there is 1000% homeostasis questions on sugar, water, salt. If you have a look, I use my template answer to do those big paragraph questions. Okay. Before I go through the menstrual cycle, which we've already done in paper one, if you've written in paper one, we're not going to go over that today, unfortunately. We don't have the time to cover that. But what I am going to go over with is, I thought it would be apt to do a little bit of endocrine. And so I'm just going to zoom in. And this is also, I know it says homeostasis, and it is homeostasis, but it's the endocrine glands that I want to focus in on. So a lot of matrics don't study enough when it comes to homeostasis and the endocrine system. And that's actually what we're going to look at here, and specifically the thyroid. The thyroid is unusual because it has two hormones acting upon one structure to maintain one thing. Normally, it's not the case. And the other time that we see this interaction is with the follicle when you make an egg and you've got FSH and LH playing a role together, and then you've got estrogen and progesterone coming out of the follicle. And so just in the same way that the menstrual cycle and the ovarian cycle can be quite tricky, I think a lot of people understudy the thyroid. So I just want to go over the thyroid for my own peace of mind. This is actually a piece of the cheat sheet. I've just screenshotted a piece of the one page. And this is actually the template answer built in with an answer. So this also kind of answers someone's question earlier about what does it look like if you were to use this in a question. So if they were to ask you something about the thyroid and the fact that, let's say a person's thyroid is slowing down, right? Over here. Their metabolism is slow, which means they've got low thyroxine. How do you fix the low thyroxine? So what we'll do here is we start off with our loop. right? Now, I've actually swapped the stimulus with the receptor here, but that doesn't really matter because when you're writing a sentence in English, you can put both in the same sentence. It doesn't have to, one does not have to come before the other. You can say the stimulus is received by the receptor or the receptor receives the stimulus. You see, it doesn't matter in the order in which you write these first 2 points. But essentially, what you would need to do is if they say that someone's metabolism is slowing, you would have to acknowledge, number one, that the thyroxine level is dropping, because remember, thyroxine is for your metabolism. When the thyroxine level drops, the pituitary gland is going to register that, okay? And it is step 2. Let me just go back here. This is step 2 of our template answer. It is the receptor. It's receiving that information. So there are cells in the pituitary gland that pick that up. Now, the pituitary gland is also the control center, which is what makes this one a little trickier. And that's why I included it in today's lesson, because it is both the receptor and the control center. Okay. Now, because it's both at the same time, it's got like super, super high level abilities to control. And so what happens is the pituitary gland is going to register there's a drop, and it's going to secrete thyroid stimulating hormone. That's number 4, right? Now, thyroid stimulating hormone is the corrective measure. As we just took down now, that's the corrective measure. The corrective measure is then sent to the thyroid gland. The thyroid gland is the effector. And you can actually see it here in this diagram that's on your throat. The effector, which is the thyroid, now secretes thyroxine. So if I'm just numbering this again, this is number 5. This is now number 6. Now the effector is creating a result or a measure that it's carrying out to solve this problem, which is that the thyroid now secretes thyroxine. And this is where it's unique, because if I just move these 2 back into screen so you can see both of them, there is a hormone over here and there is a hormone over here. And that's unique because one hormone is triggering another hormone, which we don't often see this when we study this at school. So thyroxine is secreted. Now, because the thyroid is secreting thyroxine, we always forget this one. And that's why I'm going to NB this one, because a lot of matrics don't write this. The thyroid stimulating hormone then reduces. And a lot of matrics don't write that. They have to acknowledge that that goes down. So what that means is when thyroid stimulating hormone is going up, okay, when it's going up, thyroxine will follow later on, because remember it's a seesaw effect. So it takes a while for the seesaw to level out. Thyroxine goes up. When it reaches its peak, right? So when it's up here, it's high enough. We don't need no more. Because now what we need is we need the thyroxine to come up. And the only way for thyroxine to come up is for it to increase. But when thyroxine gets to its maximum and we don't need any more thyroxine, thyroid stimulating hormone is going to come down. So this one, I know, guys, is really hard to conceptualize or imagine. But think of it like this. Thyroid stimulating hormone is a stimulant. It stimulates the production of thyroxine. It stimulates it. If you have enough thyroxine, right, do you need to keep stimulating to make more? The answer is no, you don't. And that's why thyroid stimulating hormone must come down, because once you have enough, you don't need to make any more. You've made enough. I think that's the point I'm trying to get across. Last but not least, thyroid stimulating hormone reduces. And because thyroid stimulating reduces and our thyroxine is still high, we can do our final step, which is the result. your cellular respiration increases, so your metabolism increases. And so this whole loop is how we would explain thyroxine and the metabolism increasing by using the template answer. Now, some top little things that I do include in the study guide are pro tips. These tips over here are mostly for when you write exams and ultimately why you don't get full marks. So, for example, note when thyroxine levels are high, thyroid stimulating hormones reduce. As I just said now, when one is up, the other is down. Therefore, they are antagonistic. Remember, the pituitary is the receptor and it secretes the thyroid stimulating hormone to the effector called the thyroid. Okay, just keep those two in mind. We often forget them. And I think a lot of us need to maybe go back to studying the thyroid a bit more because we don't do enough of it, not nearly enough as much as you would need. Likewise with angiotensin and the adrenal gland, I don't think you study it enough, and I suggest you should. Now I'm going to just take a quick little break and a squiz at the questions, maybe if there are any in the chat. Otherwise, I'm thinking of doing like a little quick past paper question on genetics because it was the most voted section that you guys wanted me to do. And so that I actually have two different genetics questions. There's a pedigree, and then there is a genetic cross a little bit lower down that I want to cover. So, any questions? Okay, Jay says, let's say we were to describe the role of the pituitary gland in correcting thyroxine levels, 4 marks. With this type of question, do we focus solely on the pituitary gland, what it does, or the effect it has on thyroxine, or both? So question, the role of the pituitary gland in correcting. Yes. So to answer your question, Jay, if you were to describe the role the pituitary gland plays in correcting thyroxine, then yes, you will need to explain its effect on the thyroid and then how the thyroid feeds back to the pituitary gland. Because the question is about the pituitary gland. It's not really about the thyroid. So you don't need to talk about how the thyroid makes thyroxine and then the thyroxine increases cellular respiration. No, the emphasis is on the pituitary gland and the pituitary gland's role in correcting thyroxine. So what is its role? Its role is to, number one, detect that the thyroid stimulating levels are too low. If the thyroid stimulating levels are too low, it means the thyroxine levels are too low. So it increases the thyroid stimulating hormone. That thyroid stimulating hormone is sent to the thyroid to make more thyroxine. And that's where you stop. You don't keep on going down the rest of the template answer because it's not asking for how does the pituitary gland or how does the thyroid control metabolism from, the whole homeostatic function. It's not asking that. It's not asking about homeostasis. It's not asking about the negative feedback loop. It's simply asking the pituitary's role. So only talk about the pituitary gland's role. It's a lovely question. It's a big common mistake that matrics do make. Okay, right. I'm going to dive back into questions on genetics, and this is like a past paper question. I just randomly picked something. I didn't even double check what this was on, but I chose this one because a lot of us are really bad at pedigree diagrams, and to be honest, we shouldn't be. This is from section A, which means it's a level 1 question, and nobody should be spending a huge amount of time on this whatsoever. And what do I mean by that? I mean that if this section's only out of 5 marks, you shouldn't be spending more than 5 minutes. But let's just break this down quickly. So let's look at this pedigree diagram. So, by the way, from when would I take this question from? I think this one I took from November 2022. Okay, so it's not too old. And a top tip, everyone, I wouldn't use papers beyond 2022. Once you start doing 2021 and 2020, that date, that information, and those examiners have been outdated a bit and they've been replaced. So you want to do the most recent exams because they're the new examiners. But anyway, so it says we have a disorder. The disorder is Moya. It's a disorder caused by a dominant allele. We use the letter R, and we know it's dominant because of the capital R. This disorder damages the arteries supplying blood to the brain. We have the inheritance. And so first things first, I am hoping automatically everybody knows this is not a sex-linked disorder, because they only gave us the letter R. There is no X with an R on it. They will tell you. Either they will say it's a sex-linked disorder, or they would have given you the X with the R in brackets, which they didn't, right? So don't stress about overthinking it. This is a dominant allele that causes this disease. Now let's look at the table. Should I say the pedigree diagram, and just kind of fill in all the individuals that we're very certain of. So for example, it says here we have affected males and affected females, and they are colored in. Please don't be thrown by the word affected. Male and female, that's just telling you they're males and females, not that you have to put X's and Y's. You don't need to put X's and Y's in this cross. It's not a sex-linked disorder. This is an autosome problem. So because it's autosomal, you're only going to use the letter R and R. So a big R and a little r. Now, every single individual who's colored in here must have a capital R attached to it. If you are an unaffected male or female, you must have two small r's. So again, this makes this really easy to fill in, because if that's the case, I can fill in every single person on this table or in this pedigree diagram really quickly. Now all I need to do is just go back to these individuals who are affected and decide, are they homozygous or heterozygous? Now, the moment you have an individual like D that comes from the parents A and B, you already know that because B has two small r's, we already know that one small r must have come from B and the other small r must have come from A. So I can fill that in automatically, like already. Likewise, if we go down to G and we figure out what we want to figure out what C is, you look at the parents to help you make the children, but the children can also help you make the parents. The fact that G has one little r, which we got from D, the only other way this little r is inherited is from this parent, right? If we go over to these children here, I and J, we need to figure out what are their letterings. Well, the fact that F has two small r's and H has a small r, the other small r can only come from this parent in the red. Okay, it's just not happening for anybody here that we can see. And I'm just double checking as I look at my screen now, but that's definitely the case. So now that I've filled that in, and you can do this quickly, right? You don't need to spend a lot of time. Look how quickly we did it together. How many generations are in this page? Well, we've got 1, 2, 3. Remember, generations are speaking to lineages or the amount of like levels of children and offspring, including the parents. So we've got 3. Then it says, give the letters of the unaffected males. So we look here. This is also so easy, guys. Come now. Unaffected males. Remember, those are uncolored in circles, which in this case is going to be H. I think that's the only unaffected male. Let me just double check. Yep. Then it says, give the genotype of A, which we've already worked out. It's going to be big R, little r. Don't forget, this says genotype. Sometimes they like to fool you and put genotype first, and the next question is phenotype, and you get confused, and you do both genotypes instead of genotype and then phenotypes. Just keep your wits about you. And then last but not least, give the letters of the individuals not biologically related to A and B. In other words, who in this diagram is not A and B's children or grandchildren? And so the answer can only be C and F, because those individuals came from outside of this family tree. Otherwise, D and E are siblings, and those siblings have had children with their partners, and now G, H, I, and J are all grandchildren. So for our last answer there, we would say C and we would say F. And look at that, 5 marks in the bag, easy peasy, right? This is easy peasy genetics. Now let's up the ante and do difficult genetics. I've actually done a video on these 2 questions before. And I think this is sometimes the hardest question, one of the most challenging questions I've seen in a long time in exams. And this goes back all the way to 2019. I haven't seen such a challenging question in genetics in a long time. And that might be for many reasons. It might be because they got criticized that this was too challenging for children. Maybe they thought it was too challenging for second language English speakers. There's lots of things. This question also disadvantages English speakers as well. And I'm going to show you why soon. I have a whole walkthrough video of how to answer this question, and it's found in my playlist. It is the matric exam question playlist where I walk you through, and you want to look for the ones with the snails on it. It's got pictures of snails. Again, I actually selected this question as a walkthrough in my cheat sheet because it's so difficult and a lot of people don't understand what is going on. And for 6 marks, it's a lot to lose out on. So I just want to walk you through it quickly, and then I'm going to show you what you would do in order to figure this out, because that's the hard part, is figuring out what to do. It says in a certain marine vertebrate, the color of the shell is under control of 1 gene, but 3 alleles. That's an important piece of information. In different combinations, those 3 alleles can produce organisms that are orange, yellow, and black. Only 3 alleles. How can you have 4 colors? Surely there should only be 3 alleles, 3 colors, or 2 alleles, 3 colors. Because remember, you get the intermediate, the mixture, and that's the point. You can get a mixture, you can get an in-between color. But then you're thinking, but then where does the 4th one come from? Because I don't understand. It's orange and yellow, fine. Orange, yellow, fine. Where does the black come from? Like, it doesn't make sense. Like, where would that color come from? I want everybody to just pause in an exam when you come across a question like this, where you feel like you do not know enough, you don't have enough knowledge. You need to think to yourself, is there any other time I've ever done an example or a topic or a thing, something in genetics, where there are 3 alleles, but 4 outcomes? Is there any time that you've studied something where you've had multiple alleles, meaning more than 2 alleles, more than 2, and you've had different combinations? And the answer is, everybody, blood groups. This question is a blood group question disguised as a color of the shell of these snails or these marine invertebrates. And I'll prove my point, because in blood you have A, B, AB, and O. Is that not the same as orange, yellow, black? Surprise! It is the same thing. Just now they've applied it to the shell color instead of blood grouping. Now what they did is they didn't tell you any more information. The next hard part is they took the cross and they put the results of crossing different snails with each other to show you who is dominant and who is recessive. Now, this requires knowledge. This requires deep interpretation. If you don't know your ratios, you don't know how the laws of dominance work, and you also don't understand blood groupings, then this question, she was not for you. This was a question that went right over many people's heads. And this question I actually marked back in 2019 as a senior marker. And I felt really bad for the matrics of that year because they did this question really poorly because they didn't know what to say. They couldn't express themselves. I just want to run you through how we actually figure everything out. They gave you a table with crosses. So we had cross 1, 2, 3, and 4. And then they gave you what the parents were, which is useful because we know that if they start off certain colors and they produce other colors, It reveals something about the genetics. So let's just actually have a look. In the first grouping, we had yellow times yellow, and we got 27 yellow individuals, but we got 9 black. That already tells me, that's interesting. That means yellow must be dominant, right? Dominant. And black must be recessive already off the bat. But I can't believe that from one cross, because that's not how genetics works, right? You can't just cross it once and know. You got to cross a couple times. Then they did a black and black cross, and they gave all black. Now, does that tell me that black is dominant? No. Does it tell me it's recessive? No. It just tells me that however we make the color black, we are going to need a special combination to just get black. So this is very, very clever of the examiner. This cross number 2 is not useful to you right now. It's only useful to you once you understand 3 and 4. It's very, very clever how they set this up. If you go into the next one, orange times orange, we see the same outcome. Orange is a bigger proportion than black, which means yet again, orange is dominant. But now you're sitting thinking to yourself, but how can yellow be dominant and orange be dominant? Well, isn't that possible when you have incomplete dominance, when neither of them are dominant? So they take up equal space. And now this last cross where they crossed orange and yellow, and they made orange yellow, all of them were orange yellow. This is where first language English speakers would be disadvantaged. And let me explain. When you speak English, or when you write English, or when you just naturally say a color in English, if you say orange dash yellow, in English, that means it's actually an orangey yellow color. It means it's like a mixture. But in this exam, it says orange dash yellow, which means that the examiner meant it as it's orange and yellow, not orangey yellow. And a lot of first language speakers thought that that dash meant it was a mixture when it wasn't. It wasn't a mixture. Now, to kind of support the examiner here, they want you to pick up that yellow is dominant and orange is dominant. And the fact that they are dominant over another color means that you can't have incomplete dominance. You cannot have a mixture. You have to have co-dominance, because that's the only way you can have 2 alleles or 2 traits that are equally dominant and therefore equally expressed. So I also understand the examiner here, but it's very challenging. It's very tricky. Only people who have a really good understanding of genetics would have smashed this answer, and not enough people did. I think what I'm going to do is I'm going to leave it there, because if you actually want me to go through this, you can watch the video where I explain this whole question. I also explain the companion question below on frogs and spotted frogs. Again, it is in the playlist of exam questions. It has frogs on it, so it's very easy to see straight away if you scroll through the list. There's a lot of past paper questions I've done there. And before we go into before we go into finals, I'm going to take the 2024 papers and I'm going to make a whole bunch of videos on that for you guys to watch as well, because I know that you'll want to practice this year's mid-year exam questions. And by the way, those questions will be coming out shortly. The government will release those papers for you. I have a copy, but the official release will only come out much later once we're done with mocks. But I think that's where I am going to leave it for today. I'm just going to quickly graze my eyes upon the question section or the chat. Okay, Jay asks, in this pedigree, how can we be sure that moya is caused by a dominant allele and not recessive? Could this same diagram also fit a recessive? So just to answer you, Jay, I think I did actually answer you already. Let's actually zoom out and find the question. Where is the question? Oh, there she is. I think I already explained that. Besides the fact that they said it was dominant, because they actually say it's dominant, they give you the capital R. So you already know this disease is caused by a dominant disorder. But I understand your thinking. If they didn't give that to you, could this also be recessive? Yes, it could, but they'll tell you. They'll tell you it's recessive. Or if they don't, they'll just give you a little R in the bracket here. They'll say little R, and then you know it's a recessive allele. And then Zabia asks, can I explain the difference between homozygous and heterozygous? That's easy peasy. Basically, the difference between homo and heterozygous is the allele collection. So homo means the same. So you get homozygous recessive, which means two small r's, or you get homozygous dominant, which means you get two big letters. If something is hetero, it means it is not of the same. So one big R and one little r, and that's the difference. So these are homozygous because they're the same size letters. In case you'd missed it the first time, this is homozygous recessive, meaning it's got two recessive alleles. And this one is homozygous dominant because it has two dominant alleles. And this is heterozygous. There's nothing else to say about it. It's just heterozygous. And I think, everyone, that's where I'm going to leave this little lesson today. It's kind of a mixed bag, but I think it's been very useful for a lot of you, especially as you prepare for this exams season. And then if anyone watches this video later in the year, you'll also probably find it useful to come back to and watch. I'm probably going to do another live lesson in the final week of your mocks as well, kind of go over some more paper 2 questions. And then, guys, finals are around the you want to know the exam to come out. Members will get first dibs. You'll actually watch it long before the public will watch it. So everybody that is a member, you'll probably get to watch it a week in advance, which is great because it means you get to prepare a week ahead of everybody else. You'll be able to ask me questions on the video as well, and I'll reply directly in the chat or into the comment section. And then the public will see your prediction video much later on. But I always love to give it to everybody because I want everybody to benefit from it. But I will be doing a prediction video. Don't worry for these upcoming exams. It's the most stressful video I make because I've got to be right. I've got to try and get as close as possible to the actual exam. I've done pretty well in the previous years. And so don't miss that video. When will I be putting it out? I'll probably be putting it out in October, in early October. So look out for that, everybody. And I think that's where I'm going to end the live today. And so I'm going to see you all very soon. And I hope that you've found this useful. And don't forget to practice as many past paper questions as possible. It's the only way to be good at life sciences. And I will see you all again soon. Bye.